So I think we're still waiting a few more minutes to allow some other people to sneak in. But what I'm doing right now is setting up like a little cobbleization for what I'm about to live code with you all. Namely, we're going to sort of just put together, and everyone can follow along, a sort of, so fun fact, this third option in recent Cabal was a patch to Cabal I made a junior member of my team write last fall. It was his first open source patch ever. So I'm very proud of him. Okay, let's see. Okay, cool. We have base. There's a main file I don't care about yet. So what I'm going to, and I can make the text bigger if it's needed at some point, but right now it looks like it's not too tiny for people. Does it look fine for everyone? Not too terrible?
Just like 1 or 2 videos.
2 points?
Yeah.
Like one more?
It's fine for me.
Yes.
Okay. Okay, let me know if anyone ages suddenly, and then we can new file, module control.monoidal, where it's going to be okay, cool. So let's just review what's. Oh, I need to connect to the internet. Bloop bloop bloop. Good thing I have that passcode in my pocket. So we can. Oh wait, no, I have the docs locally. Why do I care? I don't care. So this is why I keep documentation lying around. So control.category. Let's just make sure we remember. Okay, so what I'm going to do is I'm going to first start with importing control.category, and then we're going to start writing out a few things. So so our goal is what I'm going to call a symmetric monoidal category. Now, one thing people throw around a lot is functional programming is equivalent to Cartesian closed categories. Canal-Elliott has sort of a nice package. If you Google Canal-Elliott and concat, you'll find like a cool plugin. Currently, it only works on GHC 8.0 that actually does, he has a package that basically for a pretty big, interesting subset of Haskell turns your code into sort of a first orderified representation of a Cartesian closed category representation, which you can then do all sorts of cool stuff like, I don't know, turning it into circuits that you run on hardware, some graphic stuff, calculating derivatives and whatnot. So if you Google concat and Canal-Elliott, you can find out and read his lovely papers. And so his stuff works under the assumption currently that your target is a Cartesian closed category, which corresponds with you have the availability to drop or forget or duplicate values. That's what any old lambda calculus does. What we're going to do is a symmetric monoidal category. So let's define some classes, okay? So
So do I need to know what symmetric monoid
No, you don't need to know any category theory for this talk. I'm just giving you context so you can Google words. Yes? Yes. It's a very, watch his talk. It's a really fun, good talk. I actually did a little bit of work this past weekend trying to get some of the tools at least start to resemble working on newer Haskell. There's like 1 or 2 bugs that I think Kunal still needs to track down before you can play with it in a GHC that's not 8.0. But now I added some stuff so you can use Cabal new build. You will have to use GHC 8.0 if you want to play with it this week, probably, unless you like bug hunting. So so we already are working with having a category. Let's just copy that in and have that as a comment so we don't get lost or forget about it. So we start with having, we start with just categories are things that you can compose and have an identity operation. There's a lot of interesting things that in some sort of logical framework or programming context or another, you can model this way. Functions are an obvious example. Now, we talked about 4 operators yesterday, right? One is sort of pair tuple, and that sort of works like the usual tuple, but instead of being able to project out an individual element, you get everything. You have to get all the fields out or not. We also talked about some co-product is another name. Now, important point, for those of you who were at the dependent types talk earlier, Sigma and dependent records are basically a dependent form of pair or tuple or product in terminology-wise. So when I'm saying product here, I mean it in the Haskell sense. In dependent type theory sense, that's going to be sort of an existential sum, which is confusing, but we don't need to get into that. Sum and product, that's also known as either. You have one side or the other. And then there were the 2 things that I mentioned that were funny yesterday. Choice, which is also sometimes called external choice, is sort of, there's 2 paths, both are available, but you can only get one, you have to choose one. I did mention yesterday that both pairs and choice kind of are a form of record. Linear logical pair, you can't project an individual field. You have to get all the fields at once and bind them all at once. For choice, it's the opposite in this linear setting. You only get what you pick which field, and you only get that one. Now, when you sort of relax to sort of a general intuitionistic or functional programming setting, those 2 collapse into being the same data structure a lot of the time. And then there was a thing called par, which we sort of wrote down that sort of A par B in CPS would look like, in sort of this double negation form, would look like A to empty, B to empty to empty, right? Void, empty, false, all the same idea, right? So let's at least write down some categories for these first 3, okay? Category, what's the word? So we do class, and it's going to be a category cat as like a parent constraint. It has to be a category, otherwise this is boring. And then we want a product category of cat and, let's see. Well, okay, I need to add this. to my Cabal file because all adults Cabalize their code, right? So where's source strs, expose modules? And let's actually see what the auto-generated main was. Oh, it says hello world. That's pretty cool. So we're going to want to add a few things here. So I'm about to write some code, and then so we're going to say a given category has using a functional dependency has some notion of pair. I'm going to get one or two handy errors saying I need to do enable multi-parameter classes, also functional dependencies. So let's add those now. The way I like to do stuff is write the code I want, and then let GHC remind me of what language flags to add. Multi-parameter functional dependencies. I don't know if I spelled that correctly. Looks like I did. Probably. Got some sort of, I don't know what that little, so let's talk about, so how do I eliminate a pair? So let's do pair elim. Okay, actually, so that would just be, I think that's just uncurry, isn't it? So uncurry is going to have the type pair AB A B C okay. Oh wait, I need to do, let's see. Let's see if that type checks. Maybe there's some associativity issues. Illegal type operator. Oh, I have to enable type operators to try and do clever syntax. Let's add that. Is this an acceptable pace for everyone so far?
So what is happening with anchor?
With what?
Line 40.
I wrote some code.
What does it?
Oh, the backtick is saying use. So category is basically like a more generic version of the function arrow. So this should, so if I do Cabal new REPL, let's see how that works. So if I look at T uncurry, okay. I'm going to do import prelude hiding uncurry. I reload it. Okay, so it has the wrong associativity, right? So I have to add a parentheses here. That's okay. Okay, does that look like a better type for uncurry, everyone? I can make this bigger if people want. Yeah.
So what is the connection between anchor and products?
I just wrote it. Oh wait, is that the? So actually, here's an interesting question. Should this be a map from pair in that category? Should this itself be a cap? Let's do that. We're going deep. So we have some category, and we can write little mapping things in it. We can also likewise write curry. So let's hide curry. So So this is us basically saying, yes?
Shouldn't the type of array be pair A, B, cat C, cat the rest of the table?
Oh, that's a better idea. Well, let's think about that for a moment. I think you're correct. Thank you for catching that. So let's parenthesize that. So, mean like this?
Yeah.
We could make also, so right now we're just sort of saying, let's not use Haskell arrows here. But maybe we should later. We'll revisit that. Like this is, so we're just going full deep so we can write stuff and hope it all is nice. So this lets us sort of, so we should also write curry, right? So, I don't know, that looks pretty easy. We can do some nice little copy and paste. Now, not everything is going to act like this. Products are, the reason why every programming language has them is because they're so darn obvious and easy, one hopes, ignoring issues. So, that looks good. Now, let's also have a sum category, right? Class, category, cat, sum, cat, sum, where. So I'm kind of baking in the assumption for now that your choice of category fixes the type that is going to represent your sum. So
Is that always the case?
I don't know. I have a book on category theory. Do you want to flip through it?
Sure.
Do you want to do that right now or later?
Later is fine.
Okay. I think the answer, so sometimes what will happen is these different pairing operators in the right category are actually all the same operator in various different ways. Or like we'll see that, that'll be clear in a little bit. Nothing prevents you having more than one notion of pairing that's useful. Like you could.
Could you write a bit more up on the screen?
Okay. I'll press, so interject please,
Yeah.
because I'm self-absorbed maybe. Or I just will notice it's faster.
Yeah, thanks.
Also, I don't know if you were here yesterday. I welcome interjection as long as it makes sense and is topical. So let's talk about how do we sort of write. So a thing of note here is we only really described how to. We didn't really describe how to. I guess we kind of described a way of, our curry and uncurry are sort of a way of destructing pairs and constructing pairs to a computation or into a computation, right? And everything has to be structured as sort of these compositions. So let's talk about sort of some elim. So, I don't know, we're given a function that okay, let's actually write something that does some computing. So we have sum a b, and we can go cat let's do infix r cat, and then I can drop.
You need to give a number after that, I guess.
Okay, let's make up a 5. Maybe it's 5 then cat. There's no binding.
Drop the.
Whatever. We'll have to suffer. It's okay. We'll figure it out. we can deal with cats, right? No allergies here. Okay, so what we want to do now, well, okay, actually we can do this in a pretty cute way, or we can avoid, let's just use, I'm going to ignore the sort of cute thing, and we'll just do it sort of reasonably. So we can have an A cat C cat or arrow. When in doubt, replace all your cats with arrows. There's probably a joke in there. I'm not going to go there though. This looks reasonable. This is like this. I could sort of write an instance for either for using this, right?
I think you missed the C again.
Where?
Should be some maybe to C.
Should it? So let's actually think about this. Does it have to? I think it's fine this way. Because I'm taking a sum and I'm mapping it to a thing that if I provide the right like we could probably, like you could argue that like we could so actually let's go back and so let's actually just underneath each of these sort of write these alternative simplifications, and we might go back and use them. So we don't need the C here. We could just say you give us that and you get a C, right? Mm-hmm. And okay. Now let me just have some water. So far this looks like normal functional programming done a little bit gross, right? Like, I'm sure you've all seen, oh, look how big, complicated this code with some lets gets if you only can use like curry on curry and flip and swap and things like that. Code gets really gross. We don't really care about that. We just care about sort of trying to understand the core essence of these. It's totally cool to use lets and stuff. We're just trying to do like the primitive core version of things, right? So how do we intro a sum? So this is how we remove one. How do we build one? Let's think about that for a moment. Could we just do this sort of backwards? Yeah, I guess we could. It'll look some intro. So so this is actually, okay, so yes, we can, and that'll be valid linear logically because we're going to use both functions. Wait, can we do that? Oh, yeah. So let's actually, let's just add a product category cat pair as a constraint here, and then what did I do wrong? Oh, that would explain it. Okay, now, given that we have that, can I change this to a pair? I think I can. That looks nice. Does that seem nicer? Like you know, so now if we flip this around, and if we assume, so okay, so let's actually think, there's several different ways we can flip this around, right? So first let's consider sort of the flavor using what we had before. We could make it equivalently Wait, no, this is wrong. It's not pair for sum. I'm dumb. It's going to be choice. Because only one of those functions will be used. I'm sorry for confusing everyone, including myself. Because if it's all linear, we can't use both. We actually only, so sum-elim is actually, let's make this a little bit more readable. So this is actually case sum. So what we're doing here is we are going to have a choice. What am I doing? Well, yeah, I need to define you. Hold up. Class, choice, category. Now, let's see. So we're going to assume it's a category, right? We're going to have it be cat, and we'll have a choice operator. Cat fixes choice, where. Now, how do we introduce a thing? Oh, this might get mutually recursive. Let's see what happens, okay? So, but does everyone understand sort of why I was like, wait, pair's wrong over here? We both functions are available, but we're never going to use both. We're only going to use one of them. So what we actually want to describe is that both of these are available, but you pick which one. So, so let's actually write down choice select. Now, I'm going to write type 2 equals bool. Because it's a type with 2 elements, right? Whatever. Everyone knows what a bool is. It has 2 constructors. Everything's great. You could also just do an empty sum over units. We could add some units to this. I don't really care. I don't think you guys really care yet. So we'd have a choice AB cat. Oh, I can't spell right now. Then we'd have so then we would provide a 2. Okay, how do you think we should write this? How does anyone have any thoughts about how we should write this? I'm going to figure it out in a moment. But let's sort of try and finish our sum for a moment. Okay? So because there's clearly some relationship here. Now, let's just to buy some time while I think about this. Let's recall a few things. So I was saying that not sum AB is going to be equivalent to what? I think it was not A par not B, right? Because, is that correct? No. That is going to be choice. And let's just move choice in front so it's less confusing to read. Right? Everyone comfortable with that? We'd have not pair AB is equivalent to par not A not B. Right? This is consistent with the CPS things we were just discussing yesterday. Okay, so I'm just writing this out there to help us think. So we're seeing that we need choice to exist at some point. Now, how do we define, so there's choice intro and there's so what we could do here is okay, so choice intro, I think I know what we need to do here. You give me a thing that expects a thing. I think we're going to need choice sum. So there's going to be some category, cat sum, and you provide two functions. You await one of two functions, a C cat A, some C cat B. I'm giving you a thing where you're writing a function that so you start with this, and if I have, and then that turns into a C cat A choice B. Does that look reasonable aside from am I bad at spelling?
Maybe it's higher before declaration of this.
Oh, am I spelling categories wrong? I'm confused by.
I believe you'd have to use this choice in the type class in the subcategory. I mean, subcategories should have to depend on choice as well if you want to constrain on it. Investor?
Wait, which? Okay, so 46. Let's see. Well, I didn't know I have autofolding, but it does depend on choice. So I'm a little bit confused right now.
This choice is not used later. There is in 47 line.
Okay, so you don't have scoped type variables.
Oh, motherfucker! I'm supposed to help get that or something like it added to the language. Committees are.
Explicit for all you need to use explicit for all to have it its scope.
Explicit for all changes that?
It's the scope of the type variable depends if it is explicitly or maybe.
No, but we already have it on the left-hand side.
But you need to use for all, I think.
Where? Here?
Before after the class definition, for all cut and choice and sum, I think.
What?
On the left-hand side, before yes, before this bracket.
Weird. I don't think it works that way. I'm sorry.
Okay.
I'm confused. Does anyone have it working for them? Oh, I see what the issue is. I need to hide some. Let's see. Oh. What am I doing wrong? I'm sorry. This.
Still not in scope.
But they're named over. Oh, well, let's just try. You know what? Maybe I just, here's the lazy man's answer.
There's no sum on the right-hand side.
Yeah, so we'll just do this. Remove the comma. This will fix it. It's ugly. It's gross. It's me. Ta-da! Everything got uglier, but better, right? Okay, now that it type checks, let's look at introducing a choice. So the way you sort of talk about choice, right? The way we wrote this right now, is kind of continuation-y, right? We sort of are given one of two functions, and then we get it, and then we get a thing. But this is slightly wrong, I think, right? So let's think about this for a moment. Let's instead model it as, well, okay. Well, okay. Is it wrong? Let's look at this for a moment. I'm linearly I'm being a little bit slow right now. So let's see. Should it be that or should it be the other way around? Okay, let's actually flip it around a little bit. If we are, let's comment this one out for a moment and then work on the eliminator, because I think that'll be easier, right? So choice elim could be really boring. We start with okay, choice AB, cat C, right? We can turn that. What can we do with that? We can turn that into well, we can sort of say 2. So let's just write down some operations that make sense. We can get back a sum of A cat C, or B cat C, right? Does it seem reasonable? I mean, it's kind of a hack, but actually, I might have some good. Where did I put those notes? Hang on. That's from 2015. That's a little bit too old. I have some notes somewhere over here. Sorry, I'm trying to find a little cheat sheet I wrote many moons ago, and I'm blanking on where it is right now. So a choice, it makes, choice intro actually works. We're saying you can give me, I start with a function that, okay, actually I see what I'm doing wrong. So we start with this. So, okay, so how do we extend? So let's actually write a slightly different function, and I think that'll be helpful. So we can cat a let's actually write sort of choice compose for a moment, because that's actually going to be nice. Choice, and then we'll figure out which ones are minimal. Or actually, let's do par for a moment, because that's different. That's really, really strange. And no, actually, that one has to be CPS. Okay, let's first go back from it. So far, we can talk. This makes sense for sums. We can introduce a sum this way. Now, we can, and on the flip side, we can have some sort of built in and then build choice out of that, or vice versa. So what would be the uncurried form of choice? Well, okay, so this, I'm writing this again because I'm blanking, but so people can shout out if they have good ideas, if they want to. Am I missing too many parens? No, wait, I need that. And why was this one complaining?
Because it's not properly indented.
Oh, syntax is the worst. I vote against syntax. Okay. So if I give you, okay, this is still slightly wrong. What if we rearrange it to be B and B? Okay, let's change this up. I see what I was doing wrong. So if we start with a function that, given an A sum B and returns a C, we can always map that into a choice. We can always turn that into a choice of A cat C or B cat C. I think everyone will agree that this looks like it looks more sensible, right? Everyone comfortable with this? So, because you don't know which one you're getting. You have to be able to handle either one. And then that turns into, you could just as easily say, here's the path, I have the value elsewhere, I'm going to handle it for you, right? So this is kind of like saying, here's how to encode sum. Now, so now what we can do is, so the other choice of intro is going to be we push the cats inward, right? But that's where I got stuck before, right? So actually, let's look at this for a moment. So we have, so how do we case a sum? Oh, this kind of looks like the same code. Wait, is it the same code? Yep, I wrote the same code. This is, oh, I have a typo. Why did no one catch this? Wait. So wait. Oh, let's do formatting so it's easier to read. It looks like I'm writing scheme code. It's terrible, I agree. Okay. So let's move this here. Okay. So I kind of wrote the same. So, So I'm saying, ooh, this does look bad. Let's make it less bad. Okay, so I kind of wrote the same code in both these cases, right?
Yeah, that one does not have a category at the end. The one in choice category does not have a category at the end, but
Can you say that again? I'm sorry.
it does not have a category at the end, whereas that one does.
Okay.
Yeah, you mentioned.
Are they different?
Only a little bit.
Oh, you're right. So this one's wrong, is what you're saying. I wrote it incorrectly.
I'm just saying they're different.
Okay, so how are they different? Let's think about this. And maybe I'm just writing it wrong because I'm sloppy.
At least they look different.
Okay, we take a sum. So let's make them look more similar. And then figure out, I think I just wrote the same operator twice, honestly, because they involve both. And I guess that's sort of saying, I guess so what's kind of going on here, so let's actually give this the name sum to choice. Right? Because that's kind of what's going on here.
I think the top one has cat C at the end, whereas the bottom one does not.
That is what I was pointing out.
Oh, you're right. But do we need... Oh, I see. Yes, you're correct. So let's talk about... So is it the one on the bottom is wrong? I think you're right. The one on the bottom is wrong. Because they really should be the same. Because we have this A or B, you don't know. You have to give me the tool that can handle either one, but I have to respect linearity. So let's call this sum to choice. Okay? Here, it's totally reasonable for us to actually have the opposite operation also, right? Oh wait, I do need that paren. So that'd be choice. Yeah, so that would be choice. Am I spelling choice correctly? I'm just having a moment of questioning everything. Okay, so so does this look like a reasonable eliminator? Now, we also have several other things we can do. We can compose choices, right? Which is something we can do with pairs, but not with sums. Or at least, it's much nicer to compose with choices instead of sums. So let's actually write that out.
Can we look at the choice eliminator for a second?
Sure.
Just like that I understand. So we have a choice, and it basically says if you have something from A to C, to C, then you can get a C.
Mm-hmm.
But shouldn't we also have an A or a B to then derive C?
Yes,
That would be.
that's the
like,
equivalence.
That would be like a logical eliminator.
So isn't that what we have here? That given a
The nesting seems a bit strange.
okay, so let's just write this as a comment. So we have choose. Let's just pretend we have some syntax. C. C.
Or maybe there is too much cat C in this choice.
You might be right. Do we need a cat C at the end? I don't think we do.
To have a choice to map A to C or B to C, and then we know how to reconstruct the sum,
Mm-hmm.
like pattern match on the sum.
Yeah, so this is actually an implementation of casing if we have choice built in. You're right. So if we remove the arrow cat C, this becomes the more correct way of writing it, right? Actually, let's think about that for a moment. Wait. Oh my gosh. So remember we wrote not sum A, B is equal to choose not A, not B. We just wrote that. We set C to be void or empty. Right? So we actually just wrote the correct equation. Cool. Okay, so let's go back and look at the other ones.
One second.
So could you maybe write it like with an inference rule? That would help a lot, I think.
So, okay, the rule for choice is, okay, that one's a little, let me just think for a moment. Okay, so we have gamma lets us deduce, vertical lets us deduce A. We have gamma lets us deduce B. Then we get gamma seduce choose. Let's use choose instead because choice is looking funny in my head for some reason right now. A comma B, right?
No, that's the introduction.
Yeah. Oh, you want the elimination rule?
Let's make the break in 2 minutes.
Okay, sure. So yeah, I agree. This is the intro. Now you want the elimination rule. So if we have gamma choose A, B, so we'll have a left and right elimination rule. We would have gamma A.
So how it works in my mind is you have choose A to C, B to C, and then you also have an A, right? And then you can deduce C to map on
For the intro rule?
that you made. So you have choice A cat C, B cat C. So if you like translate this, you have choice A arrow C, B arrow C, and then you have also either an A or a B. And so the left elimination then would give you C if you also know that you have A.
So so maybe I'm just not hearing you clearly, and maybe we should take a break and then we'll just resync up on this and sort of move it forward. Does that sound good to everyone? because clearly everyone needs sugar and coffee, including the speaker. Okay, so we're mostly back. So one thing I did during the break was, so that we can actually use these things, I added little arrows here so that it's a little bit easier to run when we actually start writing some instances, including perhaps,
Also, it makes more sense because that arrow is not in the same category as
Yeah.
category.
So this is in the meta category. So curry and uncurry are kind of funny. So if we have either an A or a B, is this still correct? Okay, so if we give it a choice, it has to pick one. Yeah, that looks fine.
Did they set everything with your mic?
I just put it back on. They said it was just leaving it running.
Okay, so
Okay. So we were writing some deduction rules for a moment. So let's look at pair for a moment. So this was for choose, pair. So yeah, as some people in the audience pointed out, writing out the deduction rules really is a handy trick. So if we have gamma A, if we assume, so what we can do is we can say,
As we learned from the discussion, these deduction rules are not the same as the deduction rules in visual logic.
yeah, so when I'm writing these gammas, they're a collection of linear variables. Now, in like a realistic, scaled up, linear logical programming language, you're also going to have a notion of unrestricted normal values and perhaps also irrelevant zero use and runtime relevant locations variables. Right now, all of these are just, for our purposes, all of these deduction rules are use once variables. So here I'm saying I can use my context to deduce an A or deduce a B. I can turn that into a choice. Now, interestingly, you'll notice that these elimination rules are literally the upside down version of the same. Yeah, look, this is just upside down version of these two rules. That's so maybe I'm doing it slightly wrong then.
That is how it should be read.
Or maybe it should be that. Yeah, that looks reasonable. Let's sort of go through and work out pairs. So if we have gamma, comma A and B. So okay, let me just do a little aside note. Sequent logic, if you look it up, comma on the left and this is a very important little detail. It tripped me up for like a year when I was messing with linear logic, and I was really embarrassed to realize I overlooked it. So this is like a little handy note, because if you go look up a lot of treatments of linear logic, they're usually formulated as sequent logic, which is not, it's its own thing. When you see a comma on the left of the deduction symbol or the turnstile, it's going to be usually meaning some sort of and. On the right, it's going to mean some sort of or. For those of you who don't know what sequent logic is, you can Google it, I guess. It's its own entire rabbit hole. So,
is there some linear logic resource which does not start with sequent logic?
You're asking good questions. I don't remember right now. So if we have this, we can deduce gamma A comma B C. So this would actually be, in its two forms, Curry, uncurry, right? Depending on which way we run that rule. So now let's do sum. So if we have gamma A C, we can get gamma comma A or B. We can also, so that's like, and we can also do actually we can write this.
So by or we mean sum?
Yes. I conflate a lot of things, but yes. Okay, actually, this is kind of interesting. So, so when you run these rules one way, you get sort of the constructor. When you run them the other opposite direction, you get the eliminator. Now, if we look at these left and right elims, they kind of look like our choice operations, but on the other side of the turnstile, which is sort of interesting. The duality is you switch which side of the turnstile you're on, or at least that's one way of thinking about it. Well, so in sequent logic formulations, when you negate a value, it moves to the opposite side of the turnstile. It winds up being the way those rules work. So okay, cool. So does this cover? So let's just check how that our definitions of thing make sense. So we have curry and uncurry. Did those match our rules? I think our curry and uncurry is kosher, right? Everyone's comfortable with those? And then for sum, we're saying if we have a sum, let's look at that for a moment. So to eliminate a sum, we have to provide a corresponding choice. To introduce a sum, actually, so let's just write the introduction rules for that. Does that seem valid? Actually, we can do cat, right? Okay. So those are the ways you would naturally want to construct sort of members in a sum. Does this look agreeable to everyone? That should be part of the vocabulary that you can insert things into a sum. Now, let's see. To eliminate them, so sum elimination, we can actually simplify it a bit. Well, actually, so there's some, we change it, we can optionally have a change in encoding, but there's also another rule we can do. So we can do sum A, B, cat, choice A, cat C. I guess this is mostly similar, but I'm just writing out slightly differently because this one okay. So I guess what I'm saying here is, and maybe this is actually something, so let's, so what I'm saying here, and let's just comment this one out because it's redundant, we don't need it, is given the way you actually define case is you use choice because you actually want to describe something where they're both whichever scenario, you still have access to the same environment you're working in. Okay? To eliminate a sum, you need a choice because you don't know which one you're getting. Yes?
I have a problem with the sum.
Tell me.
So choice is something that I can use left or right.
You tell it which one you want.
Yes, exactly. And so what is sum actually?
Okay, so actually I was just thinking about it. So we don't actually need this per se. What we could do is we could say which side sum. And we could have something like another,
maybe I rephrase the question. So what's the semantics of sum?
Sum is either.
Okay. So you will use if you have either
Yeah, you don't know which one until you look at it. So you have to be able to handle it.
You will use once, and the other side you will use
Once.
You will not use.
It won't exist. It's the usual sum in Haskell. Only one side exists.
Okay.
And this is why you want the built-in case operator. And what I'm saying is the right-hand side of a case.
I see. So the linearity here is on the term level.
Yeah. I'm trying to sort of stick to syntactically first order linear logic. You can have higher order logic, and that's useful, but I wanted to actually write out something that people can go and play with.
So actually choice, is there any difference between choice and sum?
They're dual. Choice, you can pick which side, and it'll.
But you need to give both of them.
Yes.
Okay.
So to eliminate a sum, you need a choice, because when you talk about a case expression, each of those scenarios is still using the same environment.
Yeah, exactly.
So this is actually one of the coolest things about linear logic. It makes thinking about cases or how you might represent them a first-class value, potentially. You still need a little bit of like smart tag dispatch machinery, like I could expose, get the tag of the sum kind of predicate, and then pass that to, and then sort of do you still need a teeny bit of trust, but the right-hand side, all those case, when you write down a case, it becomes a first-class value, which is kind of cool. And that's a good question, and I hope, did I answer acceptably?
Yeah.
So when we have a choice, so we don't really, we don't. Choice elimination is literally the same thing. So let's just comment that out, because both I kind of commented the wrong thing. Yeah.
So actually, this one more question. This choice and type, it will has to like be given by the compilers and all.
Can you restate your question with different words? So you're talking about how the type check. So this is not going to be a strictly type checked version. I'm just trying to give you a operational model that you can map to like Haskell code to think about it. Does that answer your question? Like, I'm not actually showing you a linearity statically checked embedding in Haskell with this. I hope that there's some tools for that in the near future. Like I've been talking with Kanal, and once I figure out how to get things working, I want to try and see if I can have an alternative backend that goes to a symmetric monoidal category, so I can hypothetically check for linearity on some source program. But okay, so does that? I'm not sure if I'm answering your question though.
Kind of, yes.
So okay, so let's just actually write choice intro. So given a sum a b cat c. Well, let's actually look at those rules for a moment. If we do this, oh, I already wrote that. I'm dumb. Let's just reverse this, and then we'll have the right thing. Okay. Now this looks again like the usual negation rules, right? So we can. So this is choice intro. And then we can do the opposite, which is elim. Okay, so how would we write? So let's go compare. So, yeah. Okay, so we can just do the other way around, right? Can we do a choice A, B? So what can we do here? I think I wrote this wrong. What do you guys think? So this is a little bit circular. Assuming we can case things, there's a choice available where you choose and then you just do insert left or insert right. So that's kind of boring. We can already write that down. What can we do in the opposite direction? How can we map a choice to a sum? Any thoughts? So let's actually just write down. We have not choice A, B is equal to choice A. Okay, yeah. So what we do is So wait, this was correct, and it was the other. It was the opposite direction I was doing wrong, right? Let's see. And then what we're going to do is we start with. We're basically using the CPS we discussed yesterday to write all these category operations, right? Anyone want to disagree with me or agree with me? That helps me feel very confident.
I'm not sure how you sure that you get a C. So if you have a choice A, B, the kind of type of choice A, B should be that it's producing for either choice a C, right?
Oh, I see what you're saying. So it should be C to choice A, B.
Well, I'm not sure. I'm just asking, like, how do you make sure that if you have a choice A, B, that it's going to create a C?
So actually, you're right. I'm dumb. We write down choose left and choose right. It was in front of us all along. Thank you. Choice A, B.
Can we write some instances?
Yeah, we'll get there in a second. This is cool because it's the opposite. This is okay. This is nice. I feel good again. We'll write some instances. So we still have one guy left, right? There's par, which is the dual of pair, which is kind of weird. So let's see.
Declaration for product we have not mentioned par anywhere.
Yeah, but there's a duality. So let's just try and write that. And then we'll see how far we get, right?
So if there is a duality, shouldn't there be a mention of par in the...
No, because we can get away with it with uncurrying and currying. If we were in a strictly first order setting, you wouldn't be able to use currying and uncurrying. Interesting screensaver. Okay. So does everyone want to try and work out par? Let's actually write the function, the normal Haskell function instances. So we do instance category where port qualified prelude so instance product category where curry equals p dot curry, uncurry equals p dot uncurry. Ooh, what am I doing wrong? Okay, so it's saying I'm not quite lining it up right. This is true. Okay, so
I think you switched the names of uncurry and curry.
you might be right. Should we change those here? Yep. Yes, it type checks. Thank you. Humans are really important for type checking, aren't they? So that's our product, the product category working in. Now, Haskell functions don't really enforce linearity usually, so, and even these operators we're using, we can still use let to sort of violate this. But once we evaluate a thing, we can sort of just look at it and check. But if we have it in sort of a a data type rather than the usual function category. Okay, so now we can do sum category and choice category. So let's actually define, so we have, so what's our, how are we defining our choice type? Ooh, this is annoying. Okay, we need to get it. Data choose is going to be a little tagged helper. And what we're going to do is sort of star where, okay, I have to add gadgets. Capitalization is so important. Okay, I don't need the kind signature, so I'll remove that. So choose and we'll have so we're going to have C left is going to be choose H. Oh, I did too many O's. That's really good spelling, Carter. A, B, A, C right. And then what we're going to do is we'll say data choice. Let's just do new type. It's going to be A, B, and that's going to be make choice of a function that given a choose H for all result choose okay, actually it needs to be on the inside. Oh wait, that is on the inside. For all results choose A, B, ret.
Can you explain C left and C right?
Oh, I need to have a tag. So you'll see in a moment why this works out. Now I need to allow rank and types, and then you'll see in a moment when I write the instance. So we're going to write instance of choice category. And choose right is, so we're going to say mix C F equals F C right, choose left, choice intro. Let's just leave this under error. Does it type check? Yes, it does. So this is what I actually did here is an example of how you would model co-pattern matching or immutable sort of object-oriented protocols or records in Haskell, where you have a space of tagged selectors that you pass into a polymorphic function where the final tag or whichever parameter you choose tells you the result type. How cool is that? That is, I have a little Reddit post. If you Google co-pattern matching and Haskell, that sort of has some more worked out examples of that. But okay, let's finish choice intro and sum category. And we're going to just use either because why not? And then we have case sum. So in this case, we're kind of only going to consider constructing things that will run immediately, right? We're not really dealing with variables. So we're going to cheat for a moment, if everyone's okay with that. So case sum is actually, actually we could just use, can we just use either?
So how is copatterns, what exactly are copatterns?
Copatterns are things where you define multiple scenarios, but you pick them. Choice is the simplest of co-inductive or co-pattern matching structures that aren't boring. So, like, if you want to do a immutable modeling version of objects, each method, potentially in general, results in a new object with different internal private state. You'd use choice or some sort of more general thing to describe those. And co-pattern matching, which you can fake in Haskell, which is also supported in AGDA quite nicely, gives you a really nice vocabulary for that. So let's look at that.
Why is it the dual of pattern matching?
What?
Why is it the dual of pattern matching?
Because it is. Because all the paths are available. It's why is sum the dual of choice? Pattern matching is for sums. Co-pattern matching is for selection on products. Now in linear logic, there's even more refinement and sort of nuance on top of that. Okay, so let's look at the type for case sum. So we get an either left right and a choice. And what we're going to do is we do, so that we can actually match on that, and it's going to be a mix C of F and actually I guess we have to do it case ELR of left A goes to choose right C applied to A.
Choose left.
Yes. But the type checker would tell me, wouldn't it? Oh yeah, it did. Sweet. It type checks. Holla. Okay. So how do we do choice intro? Okay, so let's write choice intro now. So we're given a function f, and we're going to return a new function x, case x of so we do.
You're missing an arrow.
I am?
Syntax is after X.
Oh yeah. But error messages would help me, right? wait. So let's look at this for a moment, because what we're doing is we're taking a function, and what we're going. Oh, okay. I see. So we do case. Well, can we actually use? Okay. So we do C right of, case X of C right, and that goes to lambda y arrow. Actually, we can just make it f dot right. Will it type check? Okay. Okay, so we can just use the prelude compose here.
So you might need p dot dot.
Where is it complaining?
Wouldn't you need p dot dot?
Damn it, you're right. How do we do this?
Just try p dot dot.
That sounds evil, but let's see if it.
Second dot with the tick.
Oh, is it?
Now the functional dependency.
Why is it complaining? It doesn't know that sum's equal to either? What if I do C dot dot? Okay, so where did I define this? This is annoying. Okay, so where did I? Okay, so we have a type error here, right?
So what does this
Can you
error
show
mean?
the definition of choice category class, please?
Oh, I see. So we're given a function that expects a sum AB.
You might need to. You are using this dot as index, right?
Shouldn't you use in left and in right?
You are using this dot as index.
Oh.
Does that work?
You're right. So you're right. Let's try that out.
With okay, yeah.
Weird. Thank you. I don't know why that didn't work. But
Because it could be, it's not fixed which sum category it is, right?
but it is.
It is?
Yeah. Oh.
Where?
In the bot. Technically, you're correct. Good job and thank you. Okay, cool. Like, has this helped everyone sort of understand what I was talking about yesterday a bit? Like, choice being this dual of either as like an interesting construct. We haven't gone to par. Do we have enough time for that? We have like 12 more minutes before people need to take their nap or something, right?
We have time up to 5 minutes.
Huh?
The room should be empty after this.
No, I thought Marcin was volunteered to do more cat theory.
Yes. Oh.
So he can then make everyone less confused or more confused, depending on his preference. How does this relate to universal properties? Tell me now.
Only 12 minutes.
What?
He will tell us in 12 minutes.
Cool. So you're saying now that we got some instances working so that it's hopefully a little bit more concrete, let's see if we can quickly bang out the par class. So let's think about that with the dualities for a moment, right? So we'd have not A, B is equivalent to par of not A, right? And likewise, we'd have, so par is actually about splitting things. So we have these curry and uncurry definitions over here. Let's actually, so it would be gamma 1 lets us deduce A, gamma 2, no, this is slightly wrong. Par's kind of tricky because you can't actually, well, let's see. Yes?
I don't know about the rest, but for me it would be extremely clarifying if you would just like explain what we just did.
Okay. So
we have seen so many things. There is like the continuations, we have choice, and we have the sum.
Yeah. Yeah, and there's
there is also linearity, but I don't think we have seen anything like what linearity is, how it works in this piece. Maybe it's completely not important.
So in this case, okay. Well, let's condense it into like a little data type that we could also write an instance for these 3, 4, right? These 3 classes. So we could have a little linear language where everything has a type. We could have and we could sort of lift all the types up. So we could have an in-right language. Let's just have, and that would look like choose A, B, arrow. I'm just trying to write some primitives. Mm-hmm.
It should be data linear AP, right?
If you have a closed language with only these operations and you don't have let, you cannot duplicate anything. Now, a missing operation here that we'd probably want to add is for each of these notions of product, we'd want a swap operator. That is one that sort of lets you move around or reassociate things. I didn't include that, but so what you'd want is for each of these operators, you want a reassociate that looks like pair A, B, C, arrow, pair A, B, C, and you'd also want a swap. And you'd also want this for each of the other, for choice and for sum. Okay? So swap would be pair A, B, pair B, A. If you only have the primitive operators that we've defined with these type classes and sort of these shuffling operations, you have a language where, subject to whatever additional primitives you add, every expression is linear. It's a very simple and very low-level language, but it's one all the same. Now, that doesn't get into how you add new data types or what primitives you choose to add to your language, but you would have it. So we could have, oh wait, this is the wrong type. So I'm just writing a bunch of primitives now. So hello.
I'll have to
I think everyone needs a break and or escape now, anyways. How's everyone feeling? Is this a good time to sort of end it, and then we can anyone who's interested can circle back and hit me up later? There's a lot of things left over, but I don't know. There's only so much you can cover in 4 hours if you're trying to sort of have it be an interactive pace of working through these things. Any questions before everyone disappears and evaporates? Okay, yes.
What kind of other things would you put in this little linear language?
Well, you'd actually add primitives to do calculations. You might have numbers. Adding 2 numbers consumes 2 things and returns a new thing. You might add data types. You might also a very important thing is for a realistic linear language, you'll also allow intuitionistic terms that can be used as many or as few times as you like. And you might also want, polymorphism, recursion, induction, and all that stuff. You might want something that's like as fancy as Haskell. Half of it just really comes down to what is the problem you want to model and what are the guarantees. This vocabulary here is really just the most minimal first order possible vocabulary you could really have. It doesn't really get into having interesting higher order functions or what you would do with that. Does that kind of answer your question? Like it's kind of the assembly language of sort of linear functional programming in a certain sense.
Oh, one of the first things you named was types, right? Would a type be a constructor in this language?
Yeah, so this so the way you'd use gaddits, and I'm not even writing it correctly now, you can embed types. Gaddits are their own fun area. I recommend anyone here who's not familiar with them read like the papers on them. They're really meant to let you embed little typed syntax trees in your host programming language. And they're a really great modeling tool. In fact, I think I showed you guys a fun party trick with gaddits, which is sort of what I consider this style of gaddit in particular is a way of sort of doing what I would consider co-pattern matching in Haskell. And that itself is its own fun modeling tool.
Yeah, so then in the little language you have like a add type, which takes a gaddit, which sets that type to some expression.
Yeah.
Yeah, so you wouldn't, like type itself wouldn't be a constructor.
It'd be in the type of the constructor. So all the primitive operations should also have what their type is in that language for how you could, like I would want to have like all, so like I might have apply, and that might take that might be a little linear A arrow B, and it'll take a little linear A and return, and the overall expression will have a type little linear B.
Yeah.
And I can keep on adding these things. I could even add lambda and variables, and then some of this other stuff. And then and that gets into certain choices about how you represent variables. You could totally have let. I could even enrich this and even say which things are linear or not, as long as I know how to check that separately. There's ways of encoding having that checking using type class shenanigans, but it's kind of gross. I didn't cover par here, but I'm quite happy that you all got to see choice. You will see very few expositions of functional programming with linear logic that actually provide choice as a first-class construct, or let you sort of play with that. And it's a really useful sort of construct for thinking about protocols.